Data Analytics 0 to Hero, Video 2, Control Flow. Video 2 of the 30-part series, Making Decisions and Repeating Work with If, Else, and Loops. If you haven't seen Video 1 on variables and data types, that's the natural starting point. Let's jump straight in. Running the cell now. Before you start, open a new Jupyter notebook in VS Code and select your Python interpreter as the kernel. Running the cell now. Once your kernel is selected, you're ready to go. And if you're following the series, subscribing means Video 3 lands in your feed automatically. Let's dive in. Part 1, If, elif, and else. Running the cell now. A score to test. If, followed by a condition and a colon, runs the indented block only when that condition is true. Since 82 is at least 70, this line runs, and prints pass. Running the cell now. This output shows that the code correctly checks if the score meets the passing criteria using an if statement. Since the score is 82, which is greater than or equal to 70, it prints pass as intended. This demonstrates how simple conditional logic can control the program's flow based on specific values. A lower score this time. The same condition. But now it's false, so this branch is skipped. Else catches every case the if didn't. And this line runs instead, printing fail. Running the cell now. Here, the code checks if the score is 70 or higher to determine a pass. Since the score is 55, which is below 70, the program correctly prints fail. This example shows how an if-else statement directs the flow based on a condition being true or false. A score to grade. The first condition Python checks. If it were true, grade would be A. Elif means otherwise. If this is true, checked only when the earlier conditions were false. If this one matched, grade would be B. Elif chains as many times as you need. This is the one that actually matches, since 75 is at least 70 but below 80. Else is the final catch-all for anything below every listed condition. If none of the above had matched, grade would be D. We print the result, C. Running the cell now. Here, the code checks the value of score using if, elif, and else conditions to assign a letter grade. Since the score is 75, it meets the condition score greater than or equal to 70 and outputs C. This demonstrates how the program selects the correct branch and stops checking further once a condition is true. Python checks each condition top to bottom and stops at the first one that's true. Order matters. A for loop runs a block of code once for every item in a sequence, like a list or a range of numbers. Part 2, For loops. Running the cell now. A list of prices. For, a variable name to hold each item in turn, then the sequence to loop over. On each pass, price holds the next value from the list, and we print it. Running the cell now. Here, the for loop iterates through each item in the prices list, printing them one by one. Notice how each price is output on its own line, demonstrating how for loops can sequentially access and process elements in a list. This reinforces the lesson's intent to show basic iteration over a collection. Range 5 generates the numbers 0 through 4. Range is the standard way to loop a fixed number of times. We print each one. Running the cell now. Here, the for loop runs 5 times, printing the values from 0 to 4. Notice how range 5 generates a sequence starting at 0 and ending before 5, which controls the loop's iterations. This demonstrates how for loops can automate repetitive tasks by cycling through a sequence of numbers. A running total, starting at 0. The same list of prices. Looping over every price. Adding it onto the running total each time. This pattern, called accumulation, is one of the most common uses of a loop. We print the final total, formatted as currency. Running the cell now. This output shows the final total of summing all prices in the list using a for loop, which iterates through each item and adds it to the total variable. Notice how the code efficiently accumulates the sum step by step, demonstrating the core purpose of for loops, to perform repeated actions on each element in a sequence. The same list. Enumerate wraps a sequence so each pass gives you both the position and the value, index and price together, instead of just the value alone. We print each one with its position. Running the cell now. This output shows how the for loop with enumerate iterates over the prices list, providing both the index and the value in each iteration. Notice that each item is labeled with its position, starting from 0, followed by its price, demonstrating how enumerate helps track the current loop count alongside the data. This is useful when you want to process items and still keep track of their positions in a list. A while loop keeps running as long as its condition stays true. You're responsible for eventually making that condition false, or it runs forever. Part 3. While loops. Running the cell now. A counter, starting at 0. While checks the condition before every pass. As long as count is below 5, the loop keeps going. We print the current count. Then increase it by 1. Without this line, the condition would never become false, and the loop would run forever. Running the cell now. This output shows how the while loop runs repeatedly as long as the condition count 5 is true. Notice it prints each value of count from 0 up to 4, incrementing by 1 each time before stopping. This demonstrates the loop's control flow, executing code multiple times until a condition changes. Break exits a loop immediately, continue skips the rest of the current pass and moves straight to the next one. Break and continue. Running the cell now. Looping from 0 to 9. Checking for the number 5. Break exits the loop entirely the moment it's hit, so anything after 5 never runs. We print each number before that point. Running the cell now. This output shows the effect of the break statement inside a loop. The loop stops entirely once the number reaches 5, so only numbers 0 through 4 are printed. Notice how the iteration ends early, demonstrating how break can be used to exit a loop based on a condition. This helps control the flow when you want to stop processing before completing all iterations. Looping from 0 to 9 again. Checking whether the number is odd, using modulo. Continue skip straight to the next number without running the rest of this pass. So only even numbers ever reach this print line. Running the cell now. This output shows the even numbers between 0 and 9 because the continue statement skips the print step for odd numbers. Notice how only numbers divisible by 2 are printed, demonstrating how continue affects loop flow by bypassing certain iterations based on a condition. This highlights the lesson's key point, using continue to selectively process items in a loop. A list comprehension builds a new list from an existing sequence in a single, compact line, often replacing a whole for loop. Part 4. List comprehensions. Running the cell now. Our familiar list of prices. The pattern is square brackets, an expression, then a for clause. This builds a new list of every price multiplied by 0.9, a 10% discount, all in one line. We print the discounted list. Running the cell now. This output shows the new list discounted, created using a list comprehension to apply a 10% discount to each original price. Notice how the length matches the original prices list, confirming that each element was processed individually. This demonstrates the power of list comprehensions for concise and readable transformations of list data. The same prices. Adding an if clause at the end filters the list, keeping only prices above 20. This single line replaces a for loop, an if check, and an append call. We print just the expensive ones. Running the cell now. Here, the code uses a list comprehension to filter out prices greater than 20 from the original list. Notice the output only includes values above that threshold, showing how list comprehensions combine filtering and iteration concisely. This highlights their power to create new lists based on conditions in a clean, readable way. We covered a lot, so let's recap. Wrap up what you learned. If, elif, and else for branching logic based on conditions. For loops for iterating over a sequence, plus enumerate for tracking position. While loops for repeating until a condition changes, and why you must update that condition yourself. Break to exit a loop early, and continue to skip to the next pass. List comprehensions for building and filtering lists in a single compact line. Control flow is how your code makes decisions and does repeated work. Video 3 covers functions and modules, so you can package this logic up and reuse it. Subscribe so it lands automatically. See you there. Running the cell now.